Swayam Prabha. Digital India. Educated India.
Namaskar. So, in this week we will start our new module, that is on two-port network. So, let us understand what is two-port network. Basically, the two-port network is nothing but a pair of terminals through which a current may enter or leave a network. Now, you can also say that if the port is nothing but an access to a network and consists of a pair of terminal, the current entering one terminal leaves through the other terminal, so that the current entering the port will be equal to 0. Now, two terminal devices or elements which we discussed till now, such as resistors, capacitors, inductors, are called as a one port network. So, that means that what we have discussed till now were the circuit like this, where we have the resistances and we try to find out the current flowing through the network. So, now if you see, when you create the Thevenin equivalent, what you do, you generally represent it like Thevenin voltage and the Thevenin resistance, and then you see that the RTH is nothing but when you look into the network from the port, what value of resistance you will see. So, here you will see that circuit is having two terminals. So, these kind of circuits are called as a one port network, because here we see only two terminals and two terminals will correspond to one single port. So, most of the circuit which we have discussed till now were two terminal or single port network, where we were representing them as a Thevenin equivalent, and we are trying to find out the various parameters of the circuit. But in general, the network can have n number of ports. So, what we will do in this particular module, we will discuss mainly the two port networks. So, what is two port network? Two port network is an electrical network with two separate ports for input and output. So, if you look at this particular figure, this is one port network where the current goes in to the linear network and comes out from the other terminal, and voltage is applied across these two terminals. So, this is basically a one port network because it is having only two terminals. If you have pair of two terminals, means you will have two ports, then what will happen, that you will give current to the network, say I1, and it will come out from the other terminal, and at the other port you will give current I2 and it will come out from the other terminal. So, what you can do, you can either put two voltage sources on both sides or two current sources on both sides, or you can put the resistor or capacitor or inductor across the terminal and try to find out the values which are required to be calculated related to that particular network. So, basically the two port network has two terminal pairs and acting as access points, like we discussed in this particular figure. So, this is the major difference between one port network and two port network. Now, to characterize the two port network, it is required that we relate the terminal quantities, that is V1, V2, I1, I2, which you see in the two port network. Here V1 is applied across terminal pair on the left side, and V2 is applied across the terminal pair on the right side. I1 flows from port 1 and I2 flows from port 2. So, what we have to do, if we want to characterize the two port network, we have to find out the values of V1, V2, I1, I2, or since we have 4 in variables, at least out of that you have to make 2 as an independent quantity, so that you can find out the circuit parameters. Now, when you say circuit parameters, basically the various terms that relate to these voltages and currents are called circuit or network parameters. So, you can say there might be V1 upon I1, V2 upon I2, or I2 upon V2, I2 upon V1, and so on. There would be multiple circuit or network parameters which we need to find out. So, what we will do first, we will try to understand the impedance parameters. What are those impedance parameters? Now, the two port network may be voltage driven or current driven, as we can see from the figure. Here at both sides we are applying the voltage source and the current is flowing to the network, or we can apply current source at both sides so that it flows inside the network. Now, to determine the impedance parameters, the terminal voltage are expressed in terms of their terminal current. So, how we will represent? If you see this particular figure, we need to find out the relationship between terminal voltage and terminal current, and what we can write, suppose there are some parameters called Z11, Z12, Z21 and Z22. So, what we can write? We can write V1 as Z11 I1 plus Z12 I2 and V2 as Z21 I1 plus Z22 I2, or in matrix form you can represent these two equations as matrix of V1 and V2, and then you will have the impedance matrix, that is Z11, Z12, Z21 and Z22, and then current vector. So, what we will write? We can write in short form as Z matrix and current vector. So, what you see the matrix in terms of Z is called impedance parameters, or you can also say the Z parameters. So, since the Z is impedance parameter, it will be represented in ohms. Now, the value of parameters, how you will calculate? The value of parameters can be calculated by setting up either current I1 is equal to 0 or current I2 is equal to 0. That means, first you will make input port open circuit, means I1 is equal to 0, or output port open circuited, means I2 equal to 0. Since these Z parameters are obtained by open circuiting either input or output ports, they are also called as open circuit impedance parameters. Now, let us see how we will evaluate the values of the Z quantities which we have seen in the matrix. Those are Z11, Z21, Z12 and Z22. So, if you put the first current I2 is equal to 0 in this particular equation. So, if you set I2 is equal to 0, you will get Z11 is nothing but V1 upon I1, and when you put I2 is equal to 0 in this equation, the Z21 will become V2 upon I1. So, you will see now that Z11 is become V1 upon I1 and Z21 is V2 upon I1. Similarly, in this equation now, if you put I1 is equal to 0, what will happen? That you will get the value of Z12, that is V1 upon I2, and Z22, that is V2 upon I2. So, by setting the value I1 equal to 0, you will get Z12, that is V1 upon I2, and Z22, that is V2 upon I2. So, this you can calculate the Z parameters or impedance parameters of the network. Now, if you see Z11 is called as a open circuit input impedance, because this is calculated when you set I2 is equal to 0. So, you will say that this is open circuit input impedance. Similarly, Z22 is open circuit output impedance, because that is also evaluated when you set I1 equal to 0. Z12 is open circuit transfer impedance from port 1 to port 2, and Z21 is called open circuit transfer impedance from port 2 to port 1. Now, to evaluate Z11 and Z21, you can find the values by connecting a voltage V1 or I1 to port 1 with port 2 open circuited. Then what you will do, you will find the value of I1, V1, V2, and then obtain the value, that is Z11 is V1 upon I1 and Z21 is V2 upon I1. Similarly, if you need to find the value of Z12 and Z22, what you will do, you will connect voltage V2 or current I2 to port 2 and keep port 1 open circuited. Then you will find the value of I2, V2 and V1, and based on these values you can calculate the value of Z12 as V1 upon I2 and Z22 as V2 upon I2. Now, you can see that this procedure can be easily understood with the help of the figure. So, in case of two port network, if you keep output port open circuit, means V2 is equal to 0, then you will get the value of Z11 as V1 upon I1 and Z21 is V2 upon I1. Similarly, if you keep input port as open circuited, that means that I1 equal to 0, then you will get value of Z12 as V1 upon I2 and Z22 as V2 upon I2. So, these two figures summarizes about how we can calculate the values of impedance parameters. Now, sometimes the Z1 and Z2 are called driving point impedances and Z12 and Z21 are called transfer impedance. Driving point impedance is the input impedance of two terminal device. So, Z12 is the input driving point impedance with the output port open circuited, while you can say that Z22 is the output driving point impedance with input port open circuited. Now, in case when you see that Z11 is equal to Z22, it means that the two port network is symmetrical. So, whenever you see that the Z11 is equal to Z22, you can simply say that the circuit is symmetrical. What does it mean? It means that the network has mirror like symmetry about some center line. So, what would be the center line? Center line would be a line that can be found that divides the network into two similar halves. So, what you can say that the two port network is said to be symmetrical if the input and output ports can be interchanged without altering port voltages and currents. Since Z11 and Z22 are equal, so you will say that the network is symmetrical, and because of the values, that is input driving point impedance for both sides are same, means the source or the voltage or current on both sides can be interchanged without any change in the circuit parameters. Now, another criteria which we have to keep in mind is that the two port network is linear and has no dependent source. So, if this is the condition and the transfer impedances are equal, that is Z12 is equal to Z21, it means that we can say that two port is reciprocal. What does it mean? It means that the points of excitation and response can be interchanged, but the transfer impedance will remain same. So, we can understand this with the help of this figure, in which at one port, that is input port, we are applying the voltage, and at the output port we are adding the ammeter to find out the value of current. So, if it is a reciprocal two port network, then if you interchange the locations of voltage source and the ammeter will give you same reading. So, in that way you can say that the circuit is a reciprocal circuit, and for that the condition which we have to verify is that first it has to be linear with no dependent source, then transfer impedances should be same, that is Z12 should be equal to Z21. Now, any two port network that is made entirely of resistors, capacitors and inductor must be reciprocal. So, this is another important property which you have to keep in mind, and when you have a reciprocal network, you can replace that network by an equivalent T circuit. So, if you see this particular T circuit, so the unknown, that is basically the network which is there inside the box, can be equivalently represented by a T equivalent circuit, where V1 I1 are the input voltage and input currents, and V2 I2 are the output voltage and output current at the other port. Now, what would be the value of T equivalent circuit parameters? So, the values of impedances for T equivalent would be like, in the left side you will see there will be the value of Z11 minus Z12, that is the first leg of T. Then on the right you will see that is Z22 minus Z12, that is the right leg of the T, and then the branch, that is Z12, which is connecting the node which is at the center and the reference node. So, with this you will see that you can represent a network which is reciprocal into a T equivalent circuit, or you can also say this is Y equivalent circuit, because Y or T are used interchangeably in the literature, but most of the time you will say that it is considered as a T equivalent. Now, if the network is not reciprocal, still with the help of the equations which we saw in the previous slides, that is V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. So, these two equations can be represented with the help of a equivalent circuit. So, here if you see, you have one impedance that is called Z11, and in series with you will have one dependent voltage source that is having the value of Z12 I2. So, what would be the value of V1? V1 you can simply write Z11 I1 plus Z12 I2. From this side, if you check that V2 is applied across the port, current I2 is flowing across the through the impedance Z22, and there is a dependent voltage source having value Z21 I1. So, now if you want to write the loop equation for this particular port, you can write V2 is nothing but Z22 I2 plus Z21 I1. So, these are the same equations which we just saw in the previous slide. So, that means that any two port network can be equivalently represented with the help of the circuit shown in the slide. So, here it need not to be reciprocal, because this is a generic equivalent network having Z parameters, while the figure which we saw above the generic circuit is T equivalent circuit, which is only applicable when your network is reciprocal. So, these are the two commonly used circuits based on the specific conditions in the analysis of circuit. Now, few more things which we have to understand in for two port network. The Z parameters does not exist for some of the two port networks, because they cannot be described by the Z parameter equations which we saw. So, if you cannot represent the two port network with the help of these two Z parameter equations, it means that those two port networks can be represented in the form of cannot be represented in the form of Z parameters. Now, what can be the example? If you consider an ideal transformer, if you see in the figure below, it is an ideal transformer having turns ratio 1:n. So, what you can write? You can write V1 is nothing but 1 by n of V2 and I1 is minus n of I2. Now, if you see these two equations, you cannot represent these two equations in the form of Z parameter equations. So, that is why in case of ideal transformers, we cannot calculate the Z parameters, but we can have the hybrid parameters, which we will discuss in the next lectures. So, we have to keep in mind that not all circuits can be converted into the equivalent Z parameters network. Few of them are like we discussed with the help of ideal transformer example. Now, let us understand the concept which we discussed related to Z parameters with the help of few examples, so that you can understand the concept more clearly. Let us see the circuit which is given in the figure. We need to find out the Z parameters for the circuit shown in the figure. Now, what we have to do? We have to first use the circuit which we discussed previously. So, what are those two circuits? First is you create the circuit when you put I2 is equal to 0, in second you put I1 equal to 0, and you will find out the value of Z parameters. So, what we are doing here? So, in the input port we are applying V1 voltage, and we will find out the current I1, while at the other end V2 is there, but current I2 is 0. So, now we know that Z11 can be represented as V1 upon I1. So, what you can write? V1 is nothing but, if you see this particular loop, since I2 is equal to 0, so V1 would be nothing but 20 plus 40 I1, and then you divide by I1, you will get Z11 as 60 ohm. Now, for Z21, Z21 is defined as V2 upon I1. What would be the value of V2? If you see this figure, since I2 is equal to 0, V2 would be applied across the 40 ohm resistance. So, if you find out the value of V2, it would be 40 I1, and then you divide by I1, you will get Z21 as 40 ohm. Now, next what you have to do? You have to keep input port as open circuit and apply voltage V2 across the output port, and we measure the value of I2. So, what would be the value of Z12? Since I1 is equal to 0, the value of V1 would be across again the 40 ohm resistance. So, the voltage across 40 ohm resistance is 40 into I2, and divide by I2, you will get value of Z12 as 40 ohm. Now, next is you need to find out the value of Z22, that is V2 upon I2. So, what is the value of V2? If you see this particular circuit, the V2 can be represented as 30 plus 40, these are the resistances, 30 plus 40 into I2. So, if you solve V2 upon I2, you will get Z22 as 70 ohm. So, now you can compile the Z matrix, which is nothing but Z11 as 60 ohm, Z12 as 40 ohm, Z21 again as 40 ohm, and Z22 as 70 ohm. Now, if you see this particular matrix, you will see that Z12 is equal to Z21. What does it mean? It means that you can represent this circuit as T equivalent. Anyway, this circuit itself is represented as T equivalent. So, this is reciprocal circuit, and when we compare with the T equivalent circuit with the circuit given in the example, you can easily find out the value of the Z parameters. How? Now, if you compare these two circuits, you can say that Z11 minus Z12 is simply equal to 20 ohm and Z12 is 40 ohms. So, simply you will get Z12 is equal to Z21 equal to 40 ohm, and then since Z11 minus Z12 is equal to 20 ohm, you can simply find out the value of Z11 is nothing but 20 plus Z12. Z12 you know that it is 40 ohm, then you will get Z11 as 60 ohm. Finally, the value of Z22 minus Z12, if you see in this figure, equal to 30. So, basically since Z12 is equal to Z21, so you can say either this as Z12 or Z21, both are same. So, what you will get? You will get Z22 is nothing but 30 plus Z12, then it is equal to 70 ohm. So, you can use either the Z parameter equations to find out these Z parameters, or you, if you know that the circuit can be represented as a T equivalent, so you can compare the circuit with T equivalent circuit and straight away you can find out the value of Z parameters. Now, let us take another example. Suppose if we are asked to find out the value of I1 and I2, the circuit, the Z parameters are given Z11, Z12, Z21, Z22. If you see in this case Z12 is not equal to Z21, so that means the circuit is not reciprocal. So, what we have to do? We have to use the Z parameter equations to find out the values of I1 and I2. Now, if we write the circuit parameter equations, that is Z parameter equations. So, V1 we can write, that is Z11 into I1 plus Z12 with this, which is J20 into I2. Similarly, V2 is J30 I1 plus 50 I2. Now, if you see the circuit having voltage V1 as 100 angle 0 and I2 that is V2 is nothing but minus 10 of I2, because I2 is in this particular direction. So, what you can write? V2 is equal to minus 10 of I2 and V1 is 100 angle 0. So, these two values we can get from the circuit. So, we can put these values in the above equation. So, we get 100 equal to 40 I1 minus plus J20 I2, and when we put the value of V2 as minus 10 I2 in the second equation and simplify, we get I1 is nothing but equal to J times 2 I2. Now, if you put the value of I1 in this equation, that is equation 1, so you can say that 100 is equal to J times 80 I2, then plus J times 20 I2 equal to 100. Then when you simplify, you will get I2 is equal to minus J, and when you put the value of I2 in the condition which we just found, that is in equation 2, that is I1 is equal to J times 2 I2, we get the value of I2 as the I1 as 2. So, what we can write? I1 as 2 angle 0 ampere, while I2 you can write 1 angle minus 90 degree ampere, because J is nothing but 1 angle 90 degree. So, we have a minus sign, so you can write one angle minus 90 degree ampere. So, this way you can calculate the value of I1 and I2. So, now we close the today's session here. We will discuss few more parameters in the next few lectures. Thank you.